In this video, I am going to use the first derivative test to find the local extreme values for f of x is equal to e to the power negative x times x cube in the interval negative infinity to positive infinity. So to use the first derivative test, we need to first find the derivative of the function. So the derivative of the function f prime of x is going to be using the product rule. E to the power negative x times 3x square plus negative e to the power negative x times x cube. So f prime of x is going to be equal to 3x square e to the power negative x minus x cube e to the power negative x, and I could factor out e to the power negative x. Okay, so f prime of x is equal to e to the power negative x. I could factor out even x square times 3 minus x. All of it, I need to set it equal to 0 to find the critical points. Now we know that e to the power negative x is never equal to 0 for any value of x. So we just need to consider these two, because all we care about is the sign of the derivative, right? So x squared times 3 minus x is equal to 0. Either this is 0 or this is 0, because you are multiplying two numbers and your end result is 0. So one or the other has to be 0, right? So if x squared is equal to 0, it implies that x must be equal to 0. And if 3 minus x is equal to 0, that implies that x is equal to 3. So we have two critical points on the number line, and those two critical points are 0 and 3. So we need to evaluate our derivative in the three intervals here. Okay, so this is interval 1, negative infinity to 0, from 0 to 3 another one, and from 3 to infinity. We could just go ahead and look at this, but x squared is always positive, right? Regardless of x value. Of course, 0 is not included here, right? So we just can look at 3 minus x and figure out the signs. So if you have a number less than 0, that means to the left interval you have, so it's going to be negative, right? So 3 minus, let's pick a number, let's say negative 1. So it's going to be 3 minus 1, which is 3 plus 1 is equal to 4. So on the left side is going to be positive. So this is going to be positive. Now pick a number between 0 and 3. Let's pick 1 or 2, doesn't matter. So 3 minus 1 is going to give you 2. That's also positive here. Interesting. Hopefully I haven't made any mistake in calculations. So let's pick another number, which is, let's say here is going to be, let's say 4. So it's going to be 3 minus 4, which is going to be negative 1. So this is going to be negative. So the signs of derivatives, to the left of 0 is positive, to the right of 0 is positive, and to the right of 3 is going to be negative. So what does this tell you about the extreme values? So first of all, at x is equal to 0, what do we get? So at x is equal to 0, using the first derivative test, we have to make a decision. That's a critical point. So to the left of 0, it's positive. To the right of 0, it's also positive. So therefore, x is equal to 0 is neither a local max, nor a local mean. So this is not an extreme value. How about 3? So for 3, x equal to 3, what happens? To the left of 3, we have positive. To the right of 3, we have negative. So according to the first derivative test, what is it going to be? To the left, we have positive. To the right, we have negative. So that tells you that x equal to 3 is a local maximum or local max. So we have used the first derivative test to find the local extreme values for this function e to the power negative x times x cube on the interval negative infinity to infinity. And we found two critical points, x equal to 0 and x equal to 3. But x equal to 0, according to the first derivative test, is neither a maximum nor a minimum, because to the left of that critical point, sign of the derivative is positive, and so is to the right of that critical point 0. But the point x equal to 3, however, is a local maximum, because to the left, positive derivative, and to the right, negative derivative. I hope that this discussion was helpful. Thank you very much.